Hey there, welcome back. In the last part of this series, we built the front end for our image moderation app. The website is now hosted and accessible through our custom domain. However, it is not doing anything at this moment. In this part, we will enable the website to upload the user selected images to S3 bucket. We'll use Lambda, API Gateway, IAM, S3, and DynamoDB. By the end of this video, we'll have a fully functional website that will allow the users to upload their images to our S3 bucket. We'll also create the first upload record of our image moderation process in the DynamoDB table. This is a fairly long video, so please feel free to skip ahead or change the playback speed if some of the concepts are already familiar to you. So as we always do, let's take a look at our architecture diagram. If you want to have more information about how we build this architecture, please refer to the part 2 of this series where we build this architecture from scratch. The section of the architecture diagram in the green circle is what we have already built in part 3 of this series. So in this part, we are going to focus on the section of the architecture diagram that is not blurred. So this part of the architecture diagram where we get the pre-signed URL from our Lambda function. Using API gateway, we pass it to the browser uploads it to the S3, and we also create our first record in the DynamoDB table about the upload process. All right, so let's get started. Okay, so let's quickly take a look at our sequence diagram for this part. Our website that we have already built will request the upload URL to API gateway. The API gateway will in turn invoke a Lambda function, which will create the pre-signed URL, and it will also create an upload record in our DynamoDB table. It will return the pre-signed URL to API gateway, and API gateway will pass on to the website, and the front end will directly upload the file to our S3 bucket. Instead of sending the file through our backend, the website is asking backend for a temporary upload link. Now this has several architecture advantages. Now remember, we could have used API gateway to upload the file directly through S3 bucket. It is possible. But the advantages of using a pre-signed URL is that our backend is not handling the actual upload part. It is orchestrating the upload, but it is not doing the heavy lifting of transferring the bytes of the file that is user has selected to the S3 bucket. It provides us better scalability because S3 is handling the upload part, browser and S3, API gateway and Lambda functions are not. It provides us with a lower Lambda workload. It also has lower API gateway usage because API gateway usage essentially is handling just a small JSON request. Okay, so now that we are clear on the sequence, let's start building the functionality. Okay, so as you can see, I have logged into my AWS console. So let's first create our S3 bucket where we will upload our image files. So we already have this one where we are hosting our website files. We are going to create a new one where the uploaded images will be stored. So let's click on create bucket. And for the bucket name, I'm going to say uploaded images, and I'm just going to put some random numbers in just to make sure that the bucket name is globally unique. Keeping it as private, so I'm blocking all public access. And I am going to create this bucket. So when we develop our Lambda function, we will upload the images in this bucket with an upload prefix. And once we analyze that image using recognition, we will change the prefix either to approved or review. Okay, but for now, we have created our bucket. Let's configure the CORS on this bucket. The reason for this is our browser is going to upload our images directly through this S3 bucket. So our S3 bucket must allow these uploads coming from our website domain. So in order to do that, go to our permissions tab and scroll down to cross origin resource sharing. So here we have to, we can provide a JSON which provides which will allow our browser to upload our images. Okay, so this is our CORS policy. So we have allowed headers all, allowed methods is put, and allowed origin, which is going to be our website, which is www.imdemo.simpleawstutorials.com. So this is our website, right? Going to save the changes. Okay. Now let's create our Lambda function. So let's open up in a new tab and go to Lambda. So as you can see, I do not have Lambda here. You can type it Lambda at the top. All right. And let's start by creating a function. Allow author from scratch. Let's name our function as getUploadURL. And I'm going to use Python 3.14. I'm going to keep rest of the settings default, and I'm going to create this function. Okay, so as our Lambda function is created, now we have to write the code. Let's create some environmental variables. To go to configuration and scroll down to environment variables, and let's add few of the environment variables that we'll use. So let's add, first one is our upload bucket. So let's add upload bucket. And what is the name of our upload bucket that we just created? So if I go back, right, this is our upload bucket's name. So I'm going to put that in here. I'm going to create another prefix. So when the images are first uploaded, what prefix they will be uploaded under, and that is uploads. I'm going to create another one because, as we have seen, our pre-signed URL is going to be valid only for certain duration. So that duration I'm going to provide as an environment variable. So you can say URL expiration seconds, and I'm going to put it as 60. So in 60 seconds, in 1 minute, this the link will cease to work. And then allowed origins, which is going to be our which is going to be our website domain. Okay, so now we have our environments variable specified. Okay, so next thing that we are going to do is to give this Lambda function permission to generate the pre-signed URL. So in general, in AWS world, whenever you are working with any resources, you have to ask yourself a question: what this resource is doing, and does it have necessary permissions to perform the actions? So in this case, our resource, which is this getUploadURL Lambda function, it's supposed to generate a pre-signed URL for our S3 bucket. And does it have the permissions to do that? Right now it doesn't. So let's provide the permissions to the execution role. So in the configuration tab, go to permissions. And if you see the role name, which is the Lambda execution role, right now it has permissions only for the CloudWatch logs. So it can make entries in CloudWatch logs, but nothing more. So let's add the permission. So click on the resource name. It will open up in a new tab. Okay. So from here, under add permissions, say create inline policy. For our service, let's choose S3. And for our actions, we need our Lambda functions to create the pre-signed URL. For that, we need put object permission. So under the right permissions, select put object. Then under the resources section, let's add our bucket information in here. So we want to provide this policy for a specific S3 bucket. So you, under the object, select add ARNs and put the resource bucket name. So I'm going to copy it from here. And for the object name, I'm going to put uploads. The reason for that is when we upload our images using front end, they will be uploaded under the uploads prefix. So I'm going to add that, click on next, and let's provide a meaningful name for this policy. So we can say something like Lambda allow s3 put object, and let's create the policy. Okay, so now the policy has been created. Now our Lambda function is able to generate a pre-signed URL for our S3 bucket so as you can, and if you refresh the execution role, you would see that it now has access to S3. Okay, now the permissions are set. So let's develop the code for this function. And I'm going to do something little bit different from the tutorials that I usually see on YouTube. I'm actually going to develop this code with you, and the reason is twofold. One is I want to make you understand the process that goes when we are actually developing a code, and the second thing, many YouTube videos actually have a perfectly written code. They copy paste it, make it available on GitHub, and that's all good, and I see the benefit doing that. It definitely reduces the amount of time that the tutor spends on explaining the code, but it takes away one of the most important things in our code development perspective, in my opinion, is the troubleshooting aspect of it. Very rarely one would write a perfect code in the first attempt itself. So there is always some tweaking, some troubleshooting, some minor fixes here and there that are needed in real life. And I want to kind of show how that is done too. So let me know in comment section what you think about it. If you think it is too long, you are more than welcome. Just download the code from GitHub and go ahead with it. If not, continue on this journey with me. Okay. So let's start with importing the libraries. So it has import Boto. Now let's import Boto 3, which is the AWS SDK. Import OS. Let's import UUID, and the reason why we are importing UUID library is we are going to create an ID for each upload, and in order to do that, we are going to use the UUID. So we are going to create a UUID from there, and I'm also going to import RE, regular expression. Okay, so then let's start with creating our client. So let's see, s3 equals, and it has already given us the auto completion Amazon queue. Okay, and now once we have created the client, I'm also going to read our environment variables. So in order to do that, I'm going to go to configuration. I want to make sure that I paste the correct names. So allowed origin is our name. So allowed origin is OS. Okay, and allowed origin. The second one is upload bucket. To do the same thing. Okay. Third one is upload prefix. Okay. And finally the URL expiration seconds. I don't know why it went on the second line, but let's, okay. All right, so and then I'm going to define another allowed content types as a list. Okay, and I'm going to say instead of GIF, because we are not accepting GIF files from our users, so I'm just going to change that to JPG. All right, so now let's do our Lambda handler. So Lambda handler is a function that gets executed when the Lambda is invoked. So let's start with that, and the event parameter in here will have the payload that is coming in from the API gateway. So let's first read our payload. So let's further put it in a try catch block, try, and I'm just going to, for now, I'm just going to the code to generate pre-signed URL. And I'm actually going to put the except block, and because that's except exception as E, and I'm going to first print string of E and the return code. Okay, so this is what I wanted to do, is now that we have our except block done, and if there are any errors, it is going to return a 500 status code with the explanation of the error. And now let's focus on our main part to generate the pre-signed URL. Okay, so let's first read the incoming payload. So let's say body equals json.loads event.body. Okay, and now that we have the payload in, let's read the information within the payload. So what information will be in this payload? So if you go back to our web page, this is what we are expecting in our payload. We are expecting the user name, user email, and the file attributes. So what file attributes will be in the payload? So we will definitely have the file name, the file type, and the file size. So going back, let's start with our, let's say, username. Let's read the username is body.get. I think we'll have to do the get, and just to be on safe side, I'm going to do username, user email is body.get user email, file name body.get file name, content type. So this is the content type of the file that the user has uploaded, body.get content type, and content length. So this is the size of the file. Okay. And you might be wondering at this stage where these variables are set. So remember, we are going backwards. We are developing this Lambda function first, then we'll hook up this Lambda function with the API gateway, and finally we will put the API gateway URL in our JavaScript file, and that is where we are going to set these parameters that the JavaScript will send to API gateway, and the API gateway will send it to our Lambda function. Okay, so now let's do some validations. So let's say for whatever reason the file name is empty in the payload, we do not want to proceed. So we say if not file name. In that case, I'm going to return a status code of 400. And I'm going to body JSON terms missing file name. I'm just going to change this a little bit. I'm just going to say file name is required. Okay. Let's say if the file that is coming in has a different content type than this. So let's say for whatever reason our front-end validation fails, we still want to handle the validation on our backend. So let's do this. So if actually that's good, that Amazon Q has already given the auto correction. I don't know if it is listening to me, or maybe it's because I have done some testing earlier with this Lambda function before I started recording this video, so maybe it remembers that context. Okay, so if content type is not in allowed content type, so the allowed content types is the list that we defined here. That is the validation for the content type. Now let's do the validation for the file size. So let's say for whatever reason there are transmission issues and file that comes in with like 0 byte file size. We need to capture that. And again, if the front-end validation fails for whatever reason and the file that is coming in is more than 5 MB, we do need to handle that. So let's handle if content length, and it has given the 5 megabyte condition first, but let's do the 0 byte first. Let's say if file content length is none. Now do or content length is greater than 5 MB. So we can say invalid file size, and that's all right. Okay, so those are the validations for our incoming one. One more validation we need to do is the file name. So I do not want any special characters in the file name, or rather I want a fixed character set that can be there in the file name. The reason for that is I don't want any file name that are coming in and can be used for directory traversal attacks, with special characters like star and all, or question marks. So I'm going to sanitize the file name. So I'm going to say safe file name. Now going to define a function which is sanitize file name, and I'm going to pass the file name that is present in our payload. So let's define this sanitize file name function. Let's go up, def sanitize file name. Now let's define this function. So let's go up, say def sanitize file name, okay. And what I'm going to do here is I'm going to replace the non-allowed characters in the file name with an underscore. So before I do that, I need to get the actual file name from if it has path information in. So let's remove the path information. So split, okay, or if it has double slash, so it will essentially read only the file name. If it has any path information in it, it will ignore or remove that. And now let's replace the characters that are not allowed in the file name. So file name is resub, and I'm going to change this actually. It's not lowercase a to z, and it has auto completed, and this is what I wanted anyways. So lowercase a to z, uppercase a to z, 0 to 9 digits, dot, underscore, and hyphen. So if the file name has any characters that are not in this set, it is going to replace those characters with an underscore. And then finally we return our file name. Okay. So now the safe file name that we have here wouldn't have any unexpected characters in it. So now let's generate our UUID. Upload ID equals str of UUID. Okay. And now let's generate the object key. So this object key is what is going to be the path of the object in our S3 bucket. So object key equals, and Amazon Q has auto completed it, but it has made one mistake. I want to keep the upload prefix, uploads for all the files that are coming in. Now it has appended the upload ID to the upload prefix. So essentially every file that is uploaded will have its own prefix. I don't want that. I want all the files to have upload prefix to start with. So actually I'm going to change this and upload ID, and I'm going to put an underscore here. So essentially the UUID underscore the safe file name is going to be our object name. The object prefix is going to be upload prefix. Okay. And now that we have all this information, let's generate our pre-signed URL. So let's say pre-signed URL. Okay, and it has already given us the autocomplete option. So let's see if this is what we wanted. So S3, this is our client that we created here at the start, right? So S3, and I'm going to turn the toggle for the full screen so we'll have a little bit more real estate to work with. So S3 generate pre-signed URL, that's the method. Put object, so bucket is our upload bucket, key is our object key that we generated here, the content type is content type, and it has metadata for the username and the user email. I'm not going to, it is not strictly required, but I'm going to keep it now that it has given it to us. Okay, and the important parameter is here, the expires in parameter. So this URL will expire in these many seconds, and that is what we have written here, and that is what we have defined in our environment variables at 60. So in 60 seconds, this URL, whatever URL that will get generated by this Lambda function will be active or workable only for first 60 seconds, and then it will stop working. Okay, so now that we have generated our pre-signed URL, let's return that information to our API gateway. So let's say return, and in this case, because it is all good, I'm going to give the status code as 200, and I'm going to say headers. What headers am I going to return? So I'm going to return the access control allow origin, and that is the allowed origin. So this our website URL, access control allow credentials true, access control allow headers, let's say content type application JSON, that's good. Let's do access control allow headers, and I'm going to put that as our content type. XAMZ date API key, this is not applicable for us right now, the security token and API key, no harm in keeping it though. And finally I'm going to say access control allowed method. Okay, options post and get. Okay, now let's define the body for our response. So body is JSON dumps, a pre-signed URL is what we are returning. We are going to return the object key. I'm also going to return the upload ID. Let's say upload ID. Okay, and I'm going to return, well, I can return, or forgot to put a, okay, and I'm going to return the bucket name, bucket. We may not need all of these parameters later, but no harm in returning in our response. Okay, so this is our Lambda function. Let's first deploy this Lambda function. So let's deploy. Let's see if it has deployed. I'll turn the, okay, so successfully uploaded the functions getUploadURL. So now that we have developed our Lambda function, let's hook up our API gateway, or let's create the API gateway and wire it up with this Lambda function. Okay, so let's open up a new tab and let's go to API gateway. Currently we do not have any API gateways, so let's create an API. For this demo I'm going to use REST API, so scroll down to where you see REST API and say build, new API, and API name I'm going to say image upload API. Description I'm just going to say this API returns the pre-signed URL to the browser. So the browser can directly upload a file to the S3 bucket. Okay. Rest everything I'm going to keep the default. I'm going to create this API. Okay, now once the API is created, let's create a resource. So select the root and say create resource. And resource name I'm going to say upload URL, upload dash URL, create resource. Let's create the post method. So let's select the upload URL resource, and let's say create method. And for the create method, I'm going to select it as post, and integration type is Lambda function, and I'm going to enable the Lambda proxy integration. So it will give us an option to select which Lambda function will be invoked. Right. So right now we only have one Lambda function in our demo OU, so I'm going to select that. This is our getUploadURL one. Rest everything I'm going to keep constant or default, and I'm going to create the method. So essentially what is going to happen is when the API gateway is called, it is going to send the request to our Lambda function, and Lambda function is going to return the response. We haven't defined that response yet, so I'm going to do that next. And then API gateway will get the response that is returned by the Lambda function. But before that, let's enable our CORS for this resource. So select the upload URL and say enable CORS. And I'm going to say access allow control methods is this. And because our request to API gateway is coming from our website, I'm going to copy the website, and I'm going to put it as our access control allow origin. I'm going to remove the trailing slash. I'm going to say save. Okay, so now the CORS is enabled, and we have done post, right? And let's define the response in our Lambda function for this post. So let's go back to our Lambda function. Let's define the response. Okay, I'm going to define it here. Again, I'm going to do the full screen. So def response status code body. So Amazon Q again has auto completed some of the things. So let's see if it is what we needed or wanted. So status code is status code, right? From here, or wherever the exception or the success one. Headers is this, content type. Okay, I'm just going to put the allow methods in there as well. So access control allow methods as options post get, and we do not have a get method, we only have options and post. That's fine. And body is JSON terms body. So again, deploy this. Now let's see if the deployment is successful. Okay, it has been successfully deployed. And now the next step is actually check or test if the API gateway is working correctly. So in order to do that, let's go to our resource, which is upload URL, right? Actually select the post method because that's what we are going to test. And in the test tab here, select that. And let's put our request body in here. So we'll send a sample request similar, and what we're expecting in that request is these things, right? So I'm just going to copy them. So for the request body, we are going to send the username, right? And for that test value, I'm just going to say John Doe, comma, user email. I'm going to say johnd@test.com. Okay, then let's say file name, right? File name. I'm going to say test underscore image.jpg, right? Content type, and for content type it is going to be the, let's say this one, the image.jpg. So I'm just going to copy it here. Okay, and content length finally, and for that I'm just going to say 1 2 3 4 5. Okay, delete this. So this is the payload that we are going to send from our API gateway to our Lambda function and see what response we get, whether it is returning the pre-signed URL or it is for whatever reason it is not working. Okay, so let's do the test. So I'm going to say click on the test button here. So it has, so now it has said internal server error. So what has happened here? So let's go back, right? And it says it has a syntax error, test invoke truncated. So let's go back to our Lambda function and see what's going on. I think that will be, let's go to CloudWatch log. So let's go to our Lambda function and let's go to monitor and click on view CloudWatch logs. So it will open up the CloudWatch, and this is our latest log. So let's open this and see what is happening here. Okay, invalid syntax on line 34. So let's go back to our code. Let's see what's happening on line 34. Okay, so yeah, so I forgot to put a comma in here. That's the reason. So I'm going to put a comma and deploy again. Okay, so now that it has deployed, let's go back and do the test one more time. So I'm going to use the same payload. Click on test in the API gateway, and again we got the internal server error. So let's see what's going on now. So it is actually returning file name is required. Let's go back to our CloudWatch logs and see what's happening again. This is our latest file log, and error, invalid syntax. Let's go back to our line 51. Okay, that's a typo. Okay, so let's deploy, and okay, so it's successfully deployed. Let's go back to our API gateway and test it again, see if third time is a charm. So click on test, and again we got internal server error. So let's see what's happening now. Again, I'm going to go to CloudWatch logs. I feel that it is easier to troubleshoot from there. Okay. Oh, looks like I forgot a comma somewhere. Line 80. Let's go back to our code again. Let's go to line 80. Oh yeah, I did. Okay. All right. So deploy again. Go back to API gateway. Let's test it. Okay, so now it's something else. So greater than is not supported between instances of str and int. and I have an idea what's going on here. But so let's go back to our Lambda function. I think the validation where we were checking the file size, that's the only place where we are comparing the numbers. Where is that validation? Oh, here. So the content length actually that is coming in here, that is a string. So let's convert this into integer first. Okay, and deploy. All right, so let's do one more test of our API gateway. Str object has no attribute spilled. That's another spelling mistake. Where did I make? Here. Split. Deploy. And test. All right, so I don't know how many times we did it, but this time was a charm. So we did get our pre-signed URL back, and we got the object key, which is uploads, and the image, right? We also got the upload ID, and this is our bucket name. So this is exactly what we were hoping to do with our API gateway and Lambda function. So what it proves right now is if the API gateway gets the correct payload and it passes that to Lambda function, the Lambda function will return the pre-signed URL back. So let's wire up our front end now to send that information over to API gateway. So let's first make changes to our JS. But before we do that, actually, we forgot to deploy the API. So let's go back to our API gateway and say deploy API. Select our uploads URL and say deploy API, and stage, I'm going to say new stage. I'm going to stage a stage name as demo or dev. I think dev should be okay. And I'm going to deploy it. So once I deploy it, it gives an invoke URL. And if you go to our post method, it gives us the post URL. So let's copy this URL and let's go back to our JS and put it here. Okay, so then we have to change the payload information in here, the variables name, email, file name. So let's put those with what our Lambda expects. So going back to our Lambda function, so we are expecting username, right? So this is going to be username. This is going to be user email. Then this is going to be file name, content type, and content length. File name, content type, and content length, GTH. Okay, so then we get the upload URL by calling the request pre-signed URL function in this JavaScript. So essentially we are passing this payload to request pre-signed URL, and if you look at the function, which is this, it takes the payload. The API URL is what our API gateway URL is now, right? And it creates a post, makes a post call, and it passes the payload to it. If the response is not okay, failed to sign, constant data. Okay, so if data API response did not include upload URL. Okay, so here we have to check. So we are not, let's see what we are returning in our response. We are not returning the upload URL. I think we are sending pre-signed URL. Yeah, pre-signed URL. So let's make that change. Include pre-signed URL. Okay, and let's return this data.pre-signed URL. Okay, so then let's going down. So we get the upload URL here, then we do upload to S3, and okay, so I think that's about it. Let me see if there are any more changes that are needed. Let's upload the script, and I think I need to change the name to script because I think I made a copy here. So I'm going to change the name to script.js and going to upload it to our S3 bucket. Okay, so going back to our website S3 bucket, so buckets, add file. I'm going to upload the script.js which I just updated. Open, upload successful. Okay, the moment of truth now. So let's refresh this page. And let's enter the name. Let's say John Doe. Email is johndoe@image.com, and I'm going to choose a file. So let's choose a file, and I'm going to select this Ford Mustang image, and I'm going to say upload. File upload failed, please try again. Okay, so when we go to the, let's inspect this error. So what was happening, or what is happening, is if you go to console, it says it still has the old API URL in here. And if I click on script.js, so even though I uploaded the correct script.js in S3 bucket, I'm still getting the old version of this JS file when I reload the website. And no matter how many times I reloaded the website, it was giving me the same thing. Even the force refreshed was not able to resolve the problem. So the way that I was able to get around this problem or resolve this problem is actually going to the CloudFront and create invalidation. So I created an invalidation record for index.html and script.js. That way, because the CloudFront distribution was still serving the old JavaScript file, and now it is loading the correct JS file. So if I go to the script file directly, I am seeing the API URL. So now let's do the testing and see if now it's going to work fine or not. So let's refresh the page, and just to be on the safe side, I'm going to say inspect. I'm going to go to sources, and I'm going to see the script.js, and now the script.js has the correct URL. So fingers crossed. So let's say John Doe @test.com, and I'm going to select the file. Okay, and I'm going to upload the file. Now it is doing something, and file upload is successful. So looks like everything went through. Now the test is to see whether we actually got the image in our S3 bucket. So going back to our S3 bucket, so this is our website. So this is not where we are uploading it. This is where the files should get uploaded. So going to the uploaded images bucket, we see upload prefix, and we see the Ford Mustang with the UUID. So looks like everything is working fine. So our website right now is able to get the user data, and it is able to upload the image to S3 bucket. So let's do the DynamoDB updates now, where we insert this record in the DynamoDB table. Okay then, so let's start with our DynamoDB table. So I'm just going to close these tabs and let's start with our DynamoDB table. I'm going to open up a new tab for our DynamoDB. I'm going to type Dynamo at the top. Okay. And currently we do not have any tables, so let's create one. Okay, so on table name I'm going to say image underscore upload requests, and for the partition key I'm going to say upload ID. So this is going to be the UUID that we generated, and I'm going to keep rest as default, and I'm going to create this table. The table is now created, so let's go back to our Lambda function. So again I'm going to open our Lambda function in a new tab, Lambda getUploadURL. So I'm going to add this table name as one of the environment variables. So if you go to configuration and scroll down to environment variables. Okay, so as you remember, we have already defined few of the environment variables. So let's add our DynamoDB as well. So click on edit, add environment variable, and I'm going to define the name as DDB DynamoDB table underscore name. And for the name, I'm going to copy the table name here that we defined, and I'm going to save it. Okay. Okay, so let's go to code tab, and I'm going to toggle the full screen mode on. So the first thing that I'm going to do is similar to how we created the client for S3, I'm going to create one for DynamoDB. So I'm going to say DDB equals boto3 dot client DynamoDB, and I'm going to read the environment variable that we just created. So I'm going to say DDB table name, and that's the os.environment.get DDB table name. Okay. So now scrolling down, so this is where we generated the pre-signed URL, and this is where we are returning the response. So between this, I'm going to add the code to insert that record in the DynamoDB table. So I'm going to say insert into DynamoDB. Okay. So then I'm going to put it in a try catch block. So try, and then just say code and accept exception as E. Okay. All right, so now let's do the code for the try block. So the client that we created, which is DDB, and if I do that, I can actually pre-fills it. So this is very important because upload ID is the partition key. So let's see if we have defined it correctly. So go back to our table, and our partition key is upload underscore ID. So I'm going to copy this. Okay. And then rest of the things are okay. So username, email, file name, content type, content length, the S3 object key, and the status is not uploaded. Let's say the status as upload URL created, because at this point we don't know whether the object is created or not. Remember, our Lambda function is just going to return the pre-signed URL back, and the browser is going to do upload. So our status should reflect that the object URL is created, or the upload URL is created. Okay, so let's deploy this Lambda function now. Now the Lambda function is deployed. We need to do one more thing, which is provide necessary permissions for this Lambda function to insert the record in the DynamoDB table. So remember, we talked about whenever you are working with any AWS resources, you need to ask yourself two questions. First question is, what is what is this resource supposed to do? And the second question is, does it have the necessary permissions to perform the actions? So in this case, this resource, which is the getUploadURL Lambda function, is now supposed to insert a record in the DynamoDB table. And does it have the permissions to do that? Right now it doesn't. So let's add those permissions. So go back to configuration tab and let's go to permissions. And let's open up the execution role in a new tab. So remember we added this policy lambda allow s3 put object for our lambda function to return the pre-signed URL. So we are going to create a policy for the lambda function to insert the record in the DynamoDB. So say go to add permissions, create inline policy, and for the service select DynamoDB. And the actions that we are going to do is put item. So go to write and select put item. And for the resources, we are going to give this permission to a very specific table, a specific action on a specific table. So go to specific and say add ARNs. And let's go back to our DynamoDB table and copy this ARN. Remove this and then add the ARN. Click next and give a name. So we can say lambda allow DynamoDB put item and create the policy. Okay, so now we have two customer created policies, customer inline policies. One is to allow our lambda function to return a pre-signed URL, and the other one is to allow the same lambda function to insert the record in the DynamoDB table. So let's go back to our lambda function, and if we refresh, now we see our DynamoDB put item allow action here. Okay. All right, so now let's go back to our front end and actually try uploading an image and see if we can do both actions where the image is uploaded in the S3 bucket using the pre-signed URL, and we also see a record in the DynamoDB table. So if you go back to our DynamoDB table first, there is an option to explore the table items. So if you click on this, so right now there are no items. So let's try to upload one record and see if it creates an item in here. Okay, so let's upload the image, a sample image. So we can just say name as something, let's say Mark Kelly, mkelly@gmail.com. So right now we are not sending any emails out. So even if this is a real email, which probably it is, we are not sending any emails out, so we should be okay. All right, so let's choose a file, and for the file I'm going to choose the Ducati file with the Ducati image in it, and I'm going to upload it. Okay, so the file uploaded successful. So let's check two things now. Let's go back to our S3 bucket and let's refresh it. So this was the one that we uploaded when we just tested the API gateway, and now we can see two. So this is the Ducati image that we uploaded. And let's go to our DynamoDB table now. So this is our DynamoDB table, and if I refresh it, I now see a record for that we uploaded. So if I open the record, so we get the upload ID, we get the content type, the file name, this is the one that we uploaded. So we get the object key, which is the path of this object in our S3 bucket. We get the status as upload URL created, and we get the username and the user email address. So now we have accomplished creating our website, hosting the website using CloudFront, Amazon Route 3 and Certificate Manager. And we have also enabled the functionality to this website where the users can enter the data and upload their images to a private S3 bucket, and we are also creating a record in the DynamoDB table for this upload. So if you like this video, please consider subscribing to the channel. If you have any feedbacks about the length of the video or the quality of the video, or in general any feedback about the content in this video, please put it in the comments. In the next video, we are going to see the application decoupling, where we will create a message in the SQS queue for our processing part of the application to read the image and start processing and start analyzing the content of the image. All right, I hope you like this video, and I'll see you in the next part.